Alright, Assalamualaikum and very good evening to all of you. So for today, I will give some lecture about the last topic, which is transducer based on piezoelectric. Before that, let's look at the piezoelectric effect. So the word piezing is from Greek, that means to press. Alright. And when we give some pressure, alright, to one crystal, right, for example quartz, barium, titanate, or tourmaline, right, so we can see that an electric voltage will be generated, right. So usually you look at the crystal is like krypton crystal, right. When you give some pressure, you will get this voltage. So the material of the crystal is like quartz, barium, titanate, and so on. Okay, and the effect is explained by the displacement of ion in crystal. So we can see that inside this crystal have a lot of ion that positive or negative. When we give some forces, so we will see that that ion will give some voltage, right. This something about this. Okay, and there are two effects of piezo. We call it longitudinal effects and transverse effect. So it is the in term of the direction of you are given a pressure or forces. Okay, and what's the relationship between displacement and the force of the piezoelectric? So when you give it some force, right, so you will get some displacement here. Okay, some displacement here, and the relationship is 1 over k times with the force that you apply. So k, that means the stiffness of crystal, which is the piezoelectric. And what is the application of piezoelectric? So it can be used as the force sensor and the pressure sensor and the accelerometer sensor. So if you remember the last chapter about the accelerometer transducer, so there are some application that have been used that use the piezoelectric, right. There are some spring there, and then when you apply some forces there, so you will get the value of the accelerometer value. And then as a force sensor, it's the same concept with the accelerometer and pressure sensor. So all of these sensor can be modeled through the second order system. Okay, and the deformation of the crystal, we give some result, what we call it the net charge Q. That is proportional with the x. Okay, the displacement. So the relationship is Q equal to kx. As we know, the x is 1 over kf. Alright, so we can say that k, the capital K over small k, we can say the D in terms of coulombs per Newton is, we call it the charge sensitivity to the force. And normally the coulomb per Newton is about 2.3 times 10 power of minus 12. And the piezoelectric is not require power supply, then the output is around 1 to 30 millivolt. This is the example of the piezoelectric transducer. We can see that this kind of what we call it device, right, this we call it this, right, is you can get it from the microphone and also the speaker, right. So it's kind like the capacitor, right. So when you apply some F here, so the relationship between the charge and also the capacitor and voltage is given to this triangle method, and it is given to Q equal to C times V. Okay, so you want to find the charge, right, you can you need to find capacitor and also the voltage supply. Okay, And the material for piezoelectric, they have been preferred quartz because of the temperature resistance to 930 Fahrenheit and so on lah. Okay, and this is the typical application. For example, it has been applied in the combustion monitoring, so you can put some piezo there as the pressure sensor, then you can measure how much the pressure of the combustion. And this is the pros and cons of the piezoelectric transducer. Okay, alright, the more important thing is about the effect, the piezoelectric effect. There are two ways the effect, which is the direct and converse effect. Directly, that's mean you supply pressure, right, to the piezoelectric. Okay, like this one. When you apply some pressure, the electrical potential or electric current will generated. And conversely effect, that's mean you give the current to the piezo. When you give the current to the piezo, you will see that the piezo will tension or compression. Okay, it will strain out, okay, and also compress. This is the picture about the piezoelectric effect. And based on that effect, we can say that the piezo can be operated as an actuator or sensor. If the piezo is used as the actuator, alright, so that's mean it is what we call it converse effect, right? That's mean you need to give some voltage, right, some input voltage, and then the actuator will what we call it will have some what we call it tension or compression. Okay, and if you use the piezoelectric as a sensor, that's mean when you give the pressure of that piezoelectric, so it will generate the voltage. So this is the good or advantage if you're using the piezoelectric, because it can operate by two type. That's mean if you want to use it as an actuator or a sensor. Okay, and the rest is about piezoelectric transducer application. It has been used in accelerometer, right? You can use the piezo, and piezoelectric motor, right? It's driven by ultrasonic vibration. Okay, if you give some wave of the to the piezoelectric, right, so you will get the value of from the piezoelectric. Does this mean that or if you give the supply to the piezo, right, so it can also generate some vibration of this motor, right? Okay, so remember the concept of speaker and mic, so and the microphone. Okay, inside the microphone it have some it have piezoelectric material, so that's mean when you give some sound, right, that's mean you give some pressure into that piezoelectric material inside the microphone, right? So that's mean it will generate an electrical current. And for the speaker, that's mean you give that current to the piezoelectric material, so that's mean the piezoelectric material will be vibrate. That's mean you that's why you will have some sound from the speaker. Okay, this is another example, the piezoelectric drill, when you also can apply some piezo there to measure how much the pressure, how much the vibration of the drill. Alright, so that's it for this chapter. It's a very short. Okay, thank you. See you again.